Hi all, good morning, good afternoon, good evening, wherever you are. My name is Vishnu Dutt, and as you know that we are into the question number 5 of our network interview preparation series. So as you all know, the intent is to not to discuss the questions, but the intent is that you learn networking to its core. You learn the fundamentals of networking, right? So having said that, what we are going to discuss in this question. So the question is basically why do we have OSI model, right? If we are already running TCP/IP model everywhere, so you all should know that whatever the internet you see today, right, it is running on TCP/IP. But in college time, as you might notice that we have also studied OSI model, right? So why OSI model if we are running TCP/IP everywhere? Okay. So one thing I would like to make sure here is that we have already discussed 4 questions, and we are now into the question number 5, right? Uh, Believe me, all these questions are interrelated, which means if you understand one, then only you can understand two. If you understand one and two, then you can understand three, and you can understand this way, right? So to understand this means that to understand this OSI model, TCP/IP, or whatever we are going to discuss in next 1 hour, maybe, right? The, it needs knowledge till question number 4, right? So go in sequence, otherwise it is not going to be it is not going to be beneficial for you, this series. Okay, so what we are going to discuss, first thing first, we are going to discuss why multiple layers. So you know that when we discuss about TCP or when we discuss about OSI, there are certain layers in that, right? So OSI model composed of 7 layers, TCP/IP model composed of 5 layers. Why exactly we need those layers? And there is a logical answer behind that. We are going to discuss it, right? Then we are going to discuss about the comparison. We are comparing TCP/IP model with OSI, and it is going to make sure that we understand these two well, and that is why the comparison, right? Then we are going to discuss where these layers are. So an interesting thing, right? Whenever I take an interview, or when I discuss all these things, the TCP/IP model or OSI model with newcomers, right? They all can explain what OSI model is, what TCP/IP model is, what exactly the layers are in this model. They can explain the layers also. But when I ask that where exactly these layers are, can I see them? Then I don't see a satisfactory answer. So where these layers are, right? Very important to understand. Then why layering? Why we have these many different layers, right? Uh, you can say that basically whatever you have written here and here are the same thing, but no. We are going to discuss why do we need data link layer when we have network layer? Why do we need two address schemes like IP address as well as MAC layer, right? And this is basically a problem of so many network engineers. So believe me, the answer is in the basics, and we are discussing basics here, right? And at last, but not the least, we are going to discuss how actually the message which we get from our application flow through our layers and then reach to the destination side. We are going to discuss about that. Right? Okay. So as I mentioned several times, that this diagram right here is going to be there for the entire series. But as I mentioned in the first question, we were discussing IP addressing, right? Second question, we were discussing how to computers talk when they are in same network. Then we discuss how to computers communicate or talk when they are in two different networks, right? Then we talk about spanning tree protocol, and here we are. We are talking about OSI and TCP/IP model. So where exactly it is fitting? So today, in today's session, we are going to discuss just a general thing about, but believe me, this general knowledge about the OSI model and TCP/IP model is a must, because whatever the concept, whatever the gap I see in today's network engineer, this is the gap. This is exactly the gap. And because of this, they are not able to understand the new technologies. So this is the basics. Just try to understand this. So you must be thinking that already 5 minutes have been spent, but yes, this video is going to be long, right? Have a cup of coffee, because I am a strong believer that if you want to learn anything, if you want to learn anything, at least you need to spend some time, right? And in some of my videos, the time goes for 1 hour, but believe me, once you reach to that 1 hour, I'll make sure that you get something out of it. And right now, we are talking about computer networking fundamentals, uh, uh, and we are going to get those fundamentals by learning OSI model and TCP model, right? So let's move to our first board here, which is how did multiple layers came into picture. Okay, so this is interesting. So sometimes, if I may say that, if I want to understand anything, for example, the problem of what we are trying to solve here is that how two computers talk, right? So if I go into the era of 1960 and around that, so there were computers. Computers were already invented, but there were talks going on that how can we make these two computers communicate with each other, right? How are they going to talk? If I say how they are going to talk, it means that if I have a file, suppose these are the two computers which I'm talking about. Here we have computer number A, here we have computer number B, right? So if these are the computers, then how these two computers can communicate with each other? And the common use case could be that if this computer has a file with name maybe ABC, how it is going to share that file with the computer number B, right? So that it can have the same file, right? So believe me, all these computer systems were there in 1960. And if I go little back, then you also understand that during the World War II, right? Mr. Alan Turing built a machine which was able to successfully decode or successfully decrypt the message of German army, right? And the code, the encryption method was Enigma, right? So I like seeing those incidents, right, in the history. So believe me, if you are a student, you know that there is a chapter in your automata book which is known as Turing machines. So the first Turing machine, which was created by Mr. Alan Turing, was this, and that is exactly your computer. So the whole sole purpose here is the computers were there, but the problem was how these two computers are going to communicate, right? So this was the problem, and most of the times, and it is my way of teaching also, that if we have a big solution, like suppose if I talk about SD-WAN solution, right? If I talk about SDXS or QoS or anything which is a complete solution, right, then it is always easier to understand it if we break it into multiple pieces, right? And that is the key of learning. So if there is any solution which is really hard to understand, if you look every piece of it together, it is going to be looking pretty hard. But believe me, if you if you break it in multiple pieces and understand those pieces to understand that piece individually and then combine it, it is going to be really easy for you, right? So the problem in the 1960 era was how to make two computers communicate or talk, right? So some intelligent guy came and he said that what we are going to do is, this is a big problem. We are going to break it into multiple pieces, right? And then we are going to work on those multiple pieces and then we combine it so that we have the complete solution. And when this guy broke this problem, it get they got multiple layers, which we know them as a layer, right? But those are the multiple pieces on which different individual or different guys are going to work to create a solution, right? For example, if I talk about application layer, so whenever you are creating this file, there must be some application associated with it, right? It means that that application is creating data, right? Which is going to be accessed by another computer. If we are talking about communicating two pieces or two computers together, right? There is an application who is creating data. It means that there must be something who is processing the data from the application, right? Or who is actually creating that data, and that is actually your application layer, right? Then what we need to do is, if we want to communicate between these two computers, A and B, the first step should be, right, whether B is there or not, right? So if I want to send a message from A to B, at least I should check that whether B is there or not, right? And that is the responsibility they have given to another piece which they call transport layer, which is right here, right? So transport layer responsibility is to check whether the receiver is there or not. And if the receiver is there, it has one more responsibility, that the application traffic, whatever I am sending, for example, if I am sending traffic of Notepad, right? Or if I'm sending of traffic of WhatsApp, then at the remote side, at the receiver side, that message is delivered to that application, right? So application to application traffic is the responsibility of transport layer, right? So suppose the application name here is WhatsApp. He is creating some data. So what transport layer is going to do? It is going to put some information in this message so that whenever it reaches to B or the receiver, we understand right there that this message is for the WhatsApp application, right? And whatever information it puts along with the data, it is known as the header, right? Header means some information along with the data I pass at the transport layer, so that at the receiver side, it is easier to read that for which application this data is for, right? So first layer, which is dealing with the application data, the second layer, whose responsibility is to make sure that the other party is there, as well as whatever I am sending with an application, it should be able, the receiver should be able to open in the same application, right? The third thing is, I have already talked about the transport layer, right? Checking the its responsibility is to check whether the device is there or not. Now here comes the network layer, where suppose before sending, transport layer was checking that the receiver is there or not. The responsibility of the network layer is very simple. It its responsibility is to send the message from A to B, right? It doesn't take care about application or all. Whatever it is getting, whatever the message is it is getting, no matter where the receiver is, in the same network or in different network, the responsibility of the network layer is that it is going to deliver this message to this host B, right? But it is not the responsibility of the network layer to deliver this message to an application, right? Because that responsibility is a transport layer, right? So this intelligent guy was coming up with all these layers, that okay, application layer is there, and it is going to deal with the application data, right? The transport layer is there to make the initial connection, that whether you are there or not, right? Network layer is there so that your data actually reaches to that host, right? Once the data reach to the host, then basically it's the responsibility of transport layer to send that data to a particular application, right? Why data link layer is there? The answer is, basically, if you want to communicate inside a particular network, then you need the data link layer, right? But I am just stopping you right now, that we are going to see the actual packet flow, how exactly happens when the network layer passes information to the data link layer, right? So that board is right after 2 or 3 boards. So I just stopped right here, that try to understand what we are doing here, right? The problem was we had computers. We need to make them talk, right? And if you want to make them talk, then basically it's a big problem. And that is why we have divided that problem into multiple pieces. And that pieces are your layers, right? And that is why these layers or individual modules come into picture. So what I can do now, I can simply put 10 people here and I can say, you are application expert. Build some protocols for me so that these two computers can talk at the application layer. I can tell the transport layer that you guys, maybe I can assign 20 people here that you guys please develop some protocols so that these two devices can talk, right? So what actually these protocols are, we are going to discuss, but the intent behind breaking this big problem into multiple problems was that basically these layers should be independent of each other, right? I can put several folks here, I can put several folks here so that they can work, right? Picture is still incomplete, and believe me, once we are done with this session, you guys should be able to understand that why we are having these layers, why not a TCP layer is all around, right? So sorry, why not OSI model is all around. So now Now you understand that there is a need of layers because we want to break a big problem into multiple pieces. That is why we needed layers, right? So there were some group of people who were solving same problem. Suppose there was 100 people in that group, and what they were doing at that point of time is they were breaking down this problem. Which problem? The problem of make sure that these two computers talk with each other, right? So what they have done is they have divided or they have broken this problem into multiple layers, right? First layer was application layer. I'm talking about OSI model now. Then the second layer came, which was presentation layer, right? So application responsibility was to deal with the application data. Presentation layer responsibility was to present that data into a specific format. Session layer responsibility was to create that initial session. Then the transport layer responsibility was whatever they are getting from the top to segment it so that segment those that information and send that information towards the receiver at the right application, right? The network layer responsibility, you know that it is responsible for sending your message from source to destination, but to which application is going to go, it is not the responsibility of network layer. Data link layer, when you want to deliver the packet or the message inside a particular network, right? Then here you come the physical layer, which talks about basically how your bits, these 1010, are going to travel across different medium, like it can go over a wire in the form of electric current or the electric current. It can go over a optical media in the form of light, and we will be discussing about it. So the whole sole point is there was a group of people, pretty intelligent people, right? They made they made a community and they were busy in solving this problem, and that's why they came across this OSI model, right? Pretty good, pretty neat. But now there was another group of people around the same time, right? So I'm talking about the era around 1970 to 1980. So OSI model people working there, and then along with that there were a group of people, maybe say 50-60 group of people, right? I'm just taking any arbitrary number, but this group was smaller as compared to OSI model, right? So there was a group of people who has the same vision that they also want these to be connected, but instead of going into all the theoretical portion, everything, they want that we need to solve this problem as soon as possible, right? So what they have done is they created a closed group and they also break this problem into multiple pieces. But because these are different people, they have broken this problem into 5 layers instead of 7 layers. So we have here application layer, we have transport layer, we have network layer, data link layer, and the physical layer. Although when this model was created, right? There were only 4 layers, but nowadays we see everywhere there are 5 layers in TCP/IP model, and we are learning the latest things. So that's why I have showcased you here the 5 models. So do not get confused. If somebody says 4 layers or 5 layers, it doesn't matter. Why it doesn't matter? Because you should understand the concept behind it. You should understand the concept behind layering. Here, the group of people think that we can make these two computers talk if I can break this problem into 5 different layers. And that's what they did. They have broken this problem into 5 different layers, right? So, and they immediately start working on it. Okay, so what is the model of OSI model? So how these guys were working? They were working on these application. What protocol should be at the application layer? What protocol should be at the presentation layer? They they created the document, initial draft. They make it public. They make it available to the public. Then public provide the comments, and they incorporated it. Actually, the complete thing was delayed with this process, right? And then these were, as I mentioned, these were intelligent people, right? And then they have backing of government, they have backing of business people or big corporations. So just try to understand that if you have 100 smart people in the room who are working on a common goal, right? It is very, very difficult to build that consensus, right? So there were fights because people were having different interests because businessmen uh, who are backing this OSI model have different interests because government who were backing this OSI model have different interests. So there was a lack of consensus in this when OSI model was coming up. So that is why the process get delayed. But on the other hand, the TCP/IP model guys, they want these computers to talk as soon as possible. So somebody was there who suggested that there should be a protocol which you know nowadays, which is a transmission control protocol, should work at the transport layer. Then at the network layer, whose responsibility to deliver these messages to end host, between host, they have developed IP, and that is why you know them as a TCP/IP model, right? They were pretty quick. They built it, they tested, and they rolled it out. So at that point of time when in during 1990 era, right, OSI model was there, TCP model was there, but these guys were slow. Even this stack was not completed at that point of time. And one more thing which this TCP/IP guys did is that they made this complete code or complete implementation free of charge. But if you want to go and read and if you want to use the OSI model, it is going to be chargeable. So you can understand if you are a owner of a particular company and if you want to see that whether everything is working fine or not, all right? So there you are going to have two options. One is TCP/IP model, readily available. Every protocol is built. You just need to download whatever the code these guys have built into your computer, and your computer is going to talk, right? But on the other hand, you have OSI model where that is still incomplete. The work is in progress. It is costly as compared to TCP/IP model. Not costly because this is free. So basically, this is on the chargeable basis. You are going to get it. So anybody has a feeling that TCP/IP model is going to give you more results, and that was happening, right? So these guys created their own network, the TCP/IP model, and then some other company come up with and they have created their own network which is built on TCP/IP. And then you can understand the other guys have also might have built their own network, and then this network is also connected, and you knew this new interconnection of network as internet. So TCP/IP model was pretty fast because people were actually using them in the production, right? they are using it to transfer real data, real files, and that is why there are a lot of networks that built at that point of time, and then those networks got connected, and which resulted into your internet. But on the other hand side, OSI model was incomplete in terms of few protocols. It was slow, it was costly, so that you can understand why TCP/IP is all over. But if if I may say, then OSI model has a pretty structured approach towards solving the problem of how to computers talk, right? So we do not want this model to go away. Even we can see this model right now, means we can see this model, we can see the specification of this model, we can see all the protocols of this model, and that is why we keep it as a reference model, right? So in your college days, whenever you see that, you read first OSI model because that is the structured approach of reading. But believe me, when we talk about practical, TCP/IP model came, they implemented it, everything is was working fine, and it is free of cost. So everybody want to see that how it is going to work. They install it, they implement it, they have created their network, they have connected their network, and that is why there is a birth of internet, right? So TCP/IP model resulted into the birth of internet, which we all know. So on every device who is connected to internet is a capable device of it has this TCP/IP model implemented. Okay, so now the question must arise that you have already answered, right? Whatever the question was why OSI model if we have TCP/IP implemented everywhere. Now what we are going to do, believe me, the intent is not just to explain you the answer of this question. The intent is to know the nitty-gritties, to know the network fundamentals, right? And with this knowledge, we can build the network fundamentals. So let's move to the new board where we are going to talk about actually where these layers are. Okay. So from now on, we are going to talk about TCP/IP model because that is we see everywhere. But but OSI model is used as a reference so that we understand that what are the various protocols, what are the various specification uh, 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 which we can use for solving this problem of talking, is how these two computers can talk. But right now, let's see what are the various layers we have in the TCP/IP. We have application layer, similarly, which deals with the application data. We have transport layer, which deals with the whatever we are receiving from the application data, how we are going to change, how we are going to put some of the information into transport layer so that it can, when it is received at the receiver, it can uh, talk to the transport layer of the receiver, right? We have network layer whose responsibility is to deliver the message between two hosts. We have data link layer whose responsibility is to deliver the message inside a particular network. We are going to discuss it. But I forgot one thing to mention you, that transport layer responsibility is also to check whether the other party is there or not, right? And if the other party is there, to which application I'm going to send this data to, right? So now the question arises, where exactly these layers are. So any device, okay, I'm just repeating once again, any device who can connect to internet, right? Any device who can connect to internet and can communicate over it has all these layers implemented, or in other words, have this model implemented, all those devices, right? So if I talk about a computer, right? Uh, when you connect this computer to your home Wi-Fi, right? So you have a router at your at your home, and this router gets connected to this laptop gets connected to the router, and then basically this device can talk to internet, right? It is as simple as that. But you must be thinking that I have never ever configured IP address on this device, but still I am able to connect to internet, or I have never ever uh, seen TCP IP into this device, but this guy is able to connect. But believe me, if you configure the IP address on this device manually, although you don't need to, because there is a protocol which is known as DSCP, and we can talk about it later at some point of time. But right now, if you open your laptop, right, then your laptop gets the IP address from this router automatically using this protocol. Protocol is just nothing but some rules through which your laptop gets the IP address from this router, right? But if you want to configure this IP address manually, you can also do that. You just, if you are using a Windows system, you just need to go into the Ethernet settings or the connection settings, and then you can see the TCP/IP uh, portion there where you can go and configure the IP address, subnet mask, right? And the default gateway and whatnot. So everything is there. So this laptop contains the complete TCP/IP model, right? Having said that, so as we discussed, basically, most of the times you do not need to configure this IP address, but when, if you want, you can. And at that point of time, you can see that TCP/IP is implemented on your laptop. So this, all these layers, right, is implemented on every computer, every handheld device, every mobile device, which is able to communicate over internet. It is as simple as that, right? So, uh, uh, let's move to our next board to see why layering. This is going to be one of the most important board because I have seen a lot of people which do not understand this. Why do we need this layering, right? So if I want to begin with something, then I want to showcase an example where I have this network layer and I have this data link layer. Now I'm talking about this router. And that is why I'm saying you need to go into a particular sequence while watching this interview preparation series because that is going to be important, right? We have discussed all these things. How do computers talk when they are in same network? How do computers talk when they're in different network? What exactly IP subnetting is? Spanning tree. We have discussed everything, right? In last 4 videos. So believe me, if you want to get something out of this board, you should go and check those videos first. Okay. But right now, if you see here, we have router. This router, say this router is R1. This router is R2. And what routers does? What routers do? Routers have routing table, and on the basis of that, they forward packet from one interface to another interface. It is as simple as that. So this router has its own routing table, right? And then I have so first of all, let me explain this topology. We have this server here somewhere on the internet whose IP address is 5.5.5.5, right? Which is connected to router R2, and then there is a link between them, which is a point-to-point link. I will be discussing about it. So, and that is connected to FA0/2. Then over the FA0/1 interface, one network is connected, directly connected, which is 192.168.1.1, 1.0. And then basically we have a specific host here. And this is connected over the technology which we all know, which is Ethernet, right? So here we have Ethernet, right? That is why this router has this routing table. Now, my question is, see, we are receiving some data from transport layer, right? Transport layer has the responsibility to say whatever the data it is sending to the network layer, it is saying that whenever I am not sure how you are going to do this, but when you deliver this data, let me showcase it with the red pen, red color. When you deliver this data, whatever I'm sending to you, just make sure you deliver it to a particular application, and the application name is app1, say, right? So this is the whole sole responsibility. Transport layer doesn't care how you are going to deliver it, but it is saying whenever you deliver, whenever you at the receiver, just make sure that this data goes to F1, right? And whatever this information, so data where from where this data came? This data came from the application, and now it has adds some information about now the transport layer added some information, this information, and that is what this information is called as the header. And because it is added by transport layer, we can say transport header. Or if we are using a transmission control protocol, we can say it as a TCP header. And most widely used protocol at the transport layer is your TCP, right? So this is called as a TCP header, and we are presuming we are using here TCP. Now, this complete information, right, goes to network layer. Now network layer says, now Mr. Network Layer, it is your responsibility to deliver this, right? Whatever I want to inform you, I have informed you. Now take this thing and go to and forward it to the destination. So this guy will take this data, whatever the data it is coming from top, and what this data is going to contain. This data is going to contain the TCP header as well as this data. So this complete information from here to here is going to be the data for the network layer. And now the network layer is going to put some more information, right? Let's draw that information as white color, this information. And what is this information? It is going to put the IP address here, the source IP address and the destination IP address, right? Although the network layer, and specifically I'm talking about IP because most of us have seen only IP at the network layer, but it is not the case. When this protocol in the development phase, there were more than one protocol which are part of the network layer, like AppleTalk and IPX. There are many protocols like that, but nowadays we are seeing only IP because IP is the dominant protocol, right? It is dominating everything, every other protocol. So at the network layer, we have IP. So right now you can see we have source IP, destination IP, which is put by the network layer or the IP layer, right? And we call it as the IP header, right? And then this is the data for the IP header, and the IP knows that this we need to send this data to the application, because if it want to check inside, it can check. But right now we are not going that way. We understand that network layer does not understand anything which is coming from the transport layer. For the network layer, it is just the data and nothing else. So it take the data, whatever is there, and it put its own header here, right? So this thing, from what happened after that, once this network layer send this information to data link layer, what exactly happens, we are going to see in this board. Believe me, very, very important board for you, right? So suppose this is my IP packet, which is coming, right? What exactly this IP packet contains? Of course, this data which is coming from the transport layer or eventually from the application layer, right? And it is going to have the destination IP address. Suppose the destination IP address is 192.168.1.10. It means this host, this IP packet wants to go to this host because the destination IP address is this one, right? Router sees that, okay, this is 192.168.1.10. I can see this is this IP address I can found in my connected route, which is connected over FA0/1 port, which is right here. So this router knows where exactly I need to forward this IP packet. And how it does know? How it knows? It knows because it has created the routing table. Routing table has that entry, and how that routing table how this routing table is created, you all know, right? Because that is explained in video number 3 or the question number 3 of this series, right? Again, I am repeating again. If you are seeing this interview series, just start in a sequence. Question number 1, 2, 3, 4, and 5. Otherwise, it is going to be difficult for you to understand. Okay. So right now, IP, because you all know routers work at layer 3, right? So they can understand the layer 3 packet. Layer 3 is your network layer. They can understand the network header also. But Does it mean that they do not understand anything else? If I say that a router is a network layer device, it means that it understands layer 3, it understands the network layer, it also understands layer 2, it obviously understands layer 1. So if I say a device is a layer 7 device, the meaning is it understands layer 7, and along with that it also understands layer 6, 5, 4, 3, 2, 1, everything, right? A switch is a layer 2 device generally, right? But nowadays, basically, most of the devices are layer 3 aware. But if I say a switch is a layer 2 device, what does that mean? It means that it does not understand IP packet at all, right? It or IP header at all. It only sees it can only understand the values which are inserted by data link layer or the MAC address or something else, right? So if I say a switch is working at a layer 2, it means that it understands layer 2 as well as L1. But yes, it doesn't have the capability of understanding layer 3, right? But now here we are talking about layer 3 device, which is a router. Router can understand layer 3, router can understand layer 2, right? It is as simple as that. So how the forwarding is going to happen? This router understand this packet needs to be forwarded at FA0/1 interface, which is right here, right? And if it wants to send this packet out of this FA0/1 interface, you understand that this is a Ethernet link, right? So on a router, the links can be different. The links can belong to different uh, technology. FA0/1 link belongs to Ethernet, which is a technology, right? A layer 2 technology. And then basically FA0/2 link, which is right here, is a point-to-point link, which is a different technology, right? It means that a router can have different links, right? Can have different data links, can have different technology links. One belongs to point to point, one belongs to Ethernet, right? But do network layer care about it? No. And it should not care about it. And that is the meaning of this layering approach. The upper layer does not care about how network layer is going to deliver the data I am sending. Suppose I am a transport layer, right? I just do not care how this network layer is going to take whatever I am sending to network layer to the destination. It is its responsibility, not mine. I would say, network layer, please take my data and just forward it to wherever it wants to go, right? Network layer responsibility is to send this data to the end host, right? Similarly, when network layer is done with reading that, okay, it's an IP packet, I need to forward it to FA0/1 interface. Network layer is pretty comfortable with that because router has read its routing table. It knows it needs to forward it to FA0/1. It is very, very simple, right? Now, when it sends it, it doesn't care how data link is going to deliver it, right? It doesn't care basically what information data link is going to put there, right? So as you know, if you are delivering this IP packet, let me draw it with the yellow color. Suppose this is my IP packet, which is having destination of 1.10, which is here. So router knows I need to forward it to FA0/1, but can it forward it? No, unless it put here another header, which is your L2 header, which needs the presence of MAC address, right? And suppose the MAC address of this guy, 192.168.1.10, is A:(A:)A. This is the responsibility of router, that before putting this IP into this layer, because Ethernet doesn't understand IP, right? Ethernet understand MAC addresses, and that is why you are going to put this A:(A:)A here, and you are going to put this packet now into FA0/1. Although source addresses are also there, but I am just talking about the destination IP and the destination MAC. And how this destination MAC address is calculated? It is already there, right? When we talk about how two computers talk in a particular network, we talk about address resolution protocol, whose main duty is to identify or to find out what is the MAC address corresponding to this IP address, right? So router does that ARP. Router initiate that ARP towards this device over this Ethernet switch obviously broadcasting this ARP packet, and that is why it got the ARP reply, and that is why it was able to create this frame at the first place and put it on the FA0/1 interface. Very simple. You all know that. But what happens? But what happens if this guy does not want to go to 192.168.1.10, but this guy wants to go to 5.5.5.5.5, right? And this 5.5.5.5 is your server right here, which is on internet, right? So the process is going to be same. Network layer doesn't understand anything. It got the data from the upper layer, the transport layer. It sees, okay, this IP packet is for 5.5.5.5 because the destination IP in the IP header is 5.5.5.5. I need to check my routing table, right? So it is going and checking its routing table. So it found a subnet here. Subnetting is a part of my first video, right? So 5.5.5.5 IP address is part of 5.5.5.0/24 network, and when it sees that if you want to reach to this network, which network? 5.5.5.0/24, you can reach it via this device. Which is this device? This device is router number 2 here, right? So to reach 5.5.5.5, right? I have a IP packet which is coming towards me, but it is going to 5.5.5.5. How I am going to send it? I am going to send it to the next hop router, and then it is going to be the responsibility of next hop router to forward it to 5.5.5.5. It is as simple as that. So the next hop router here is R2, and its IP address is 10.10.10.1. So I know, this router know, that if I want to send this IP packet now, which wants to go to 5.5.5.5, the server, I need to put it onto FA0/2 and not on FA0/1, right? Because the exit interface for this route is going to be FA0/2. It is as simple as that, right? But here is the catch here. Now we are not talking about Ethernet. We are talking about point to point. This is a different technology altogether, right? Similarly, if you go back in time, there were technologies like frame relay. There were technologies like ATMs, which you do not see them together here, right? And every layer 2 technology, which is frame relay, ATM, maybe Ethernet. Ethernet you see always because it is most widely used everywhere, right? And then point to point, there are so many technology at the layer 2. But do network layer needs to care about it? That which is what is going to be used? No, not at all. You just send your packets. Network layer is going to send its information to data link layer, and now it is its responsibility to send it across this one, right? So now this time it is the point to point link, right? Previously, the link was Ethernet, and on Ethernet, the addressing scheme was MAC, right? Because there were a lot of people can connect these switches, this switch. Already four are connected, and you need to identify, right, a single out of all these four, and that is why you needed another addressing scheme, right? So any network which hosts more than one network, more than one users connected to the similar switch or connected in a similar fashion, then you're going to need another addressing scheme because IP is not going to work there, right? That is why at the layer 2, whenever you are putting it here, because this switch is going to understand only L2 header, right? That is why you are going to put MAC addresses here so that this switch knows that, okay, A is connected here and it is going to send it here. It is as simple as that. But now we are talking about point to point. What is the meaning of point to point? The meaning of point to point is, let me explain it here with the red color. That suppose we have two endpoints. One is R1, one is R2, means router, suppose, right? and we connected them. And I know in advance that there is not going to be any other router apart from me. That is why I'm calling this link as a point-to-point link, because there is only one guy attached to this link. This is a point-to-point link, right? So here also, this link actually is your point-to-point link between R1 and R2. Do I need any other addressing scheme? Because I already know there is only one guy there, only one R2 is there, right? And OSI IP address is 10.10.1. So I do not need MAC addresses on this, because it is going to be altogether different technology, because this is a point-to-point, right? And this is your multi-access Ethernet. That is why we needed MAC addresses. But here, maybe the whatever the IP packet, let me draw it here, the whatever the IP packet you got for this 5.5.5, you are going to put another header on top of it. But is it going to be the L2 header of Ethernet? No, it is going to be the L2 header of point to point, right? And whatever this protocol is having inside this PPP, you are going to put all those information here, right? So whole sole point is one router can connect it to multiple data links. It is not the responsibility of network layer to deal with data link. And that is why we have additional layer, right? So at this data link layer, you can have frame relay, you can have ATM, you can have Ethernet, and you can have also point to point, right? So many, right? Network layer just do not care about it. It is the responsibility of this device, right, to first check to which data link layer I want to go out. And once it is decided, okay, I want to go to point link, then basically point to point header is required. If I want to go over Ethernet, then L2 Ethernet header is required, right? Otherwise, this system is not going to work, right? And that is why we need different addressing mechanisms. So if I talk about frame relay, right? Frame relay is again a multi-access network where where multiple guys are connected, right? Just like your Ethernet. And this technology is not there, but if you go back around 10 years back, the technology was there, and most of the guys were using it the WAN side, right? So over this technology, the addressing scheme was we have virtual circuits, VPCs and all, right? So just leave it for now, but try to understand, because the problem of today's network engineers are that they haven't seen these technologies. They haven't seen frame relay ATMs, and they do not need to see it. But the uh, but the problem with that is they think that there is only Ethernet. They always see this Ethernet, and then they ask this question that why do we need MAC addresses along with IP? If you understand, this is the answer of that question. Believe me, we are going to discuss it in a different video also. But if you have gone through these basics, if you understand this board well, you should figure out that why do we need another addressing scheme if we already have IP? And the reason is because we have data link layer, right? At data link layer, the links can be different. It could be a frame relay link, it could be ATM link, it could be Ethernet link, and whatnot, right? So, and every that medium, every data link has its own way of sending messages from one to another, and that is why we have created network layer, which doesn't care about all these things. Network layer responsibility should be just put the IP addresses. Its responsibility is to send the packet from one network to another network, to one host to another host, and it doesn't care about what is the underlying media, whether it's a Ethernet or ATM. It just do not care. It just doesn't care about it, right? So repeat this video, repeat this whatever we have discussed in last 15-20 minutes. It is going to be interesting. But now let's see, now let's discuss how actually information flows over these layers. Okay, so let's move to the next board where we are going to talk about message flow. Okay. So try to understand this diagram, and believe me, if you understand this, then the whole sole purpose of this complete video is going to be I will be pretty happy if you understand this board. So if you see here, we have suppose computer A here, we have computer B here, and what I want to showcase you here is I want to showcase you how actually data flows from one host to another host, right? So what exactly happens? Suppose we have this computer and I have an WhatsApp application installed here, right? Most of us are aware of WhatsApp application. We usually use it for chat. Although the analogy is not going to be fully accurate because WhatsApp uses server in the middle, but we are going to have a communication between A and B, and we are presuming that the messages are flowing directly between A and B, right? Doesn't matter whether A is part of the same network, A and B are part of the same network or different network. We are trying to understand how exactly message flow from computer A to computer B. Okay, so here we had the application layer. At the application layer, we have this data which is created by this application, which is WhatsApp application, right? Here we have the data. And now what this application says, what this application inform to transport layer, right? So first thing first, if you want to communicate to host B, you should understand that you should know the address of B. It is as good as suppose you are this person, Mr. A, right? And you want to go and meet your friend which reside at a particular community, right? Now, first thing first, if you want to meet this guy, you should understand, you should know what is the address of B, right? And it might be the case that that B is in a house where more than 10 people lives, right? You should understand, you should know the name of B also, so that when you reaches to this house here, you can go and ask that I want to meet Mr. B, right? This is the very simple thing. You understand that, right? Similarly here, if A wants to communicate to B, A should know the IP address of B. Okay, suppose B's IP address is 2.2.2.2, A IP address is 1.1.1.1. But my problem is I am using WhatsApp application here, and I want that when this my message reaches to B, B is aware that I should be open this messages into the same application, right? So what I'm going to do is, suppose this guy is running multiple application, maybe app 1, which is WhatsApp, or app 2, which is some other application, right? So this message WhatsApp application I'm telling as app 1 here, right? So what exactly A is saying? I want to communicate to 2.2.2.2, and on this 2.2.2.2, I specifically want to communicate to app 1, right? This information along with data, it says that I want to do this. It reaches to here, right? Transmission control protocol responsibility is to take this data, divide it into multiple pieces, and then add some information. And what is this information? As I mentioned earlier, this is just nothing but the header. And I'm presuming that I'm using transport control protocol or TCP here, right? That's why this blue color thing which you are seeing right here is your TCP header. And I mentioned that what is the role of TCP or the transport layer protocol? I'm not talking about UDP. The transport layer or the transmission control protocol duty is to check whether that application or sorry, whether that host or application is there or not. Let's make initial connection first. And whatever is needed for making that initial connection, they put that information into this TCP header, right? So you receive this data along with this information. What TCP is going to do, it is going to put all this information, right? That it wants to talk to app 1, right? Because once this message reaches here at the transport layer can understand this TCP header, right? It is going to check, okay, this message is for application 1, and that is why it is going to deliver it to application 1, right? because there might be more than one applications running here. App 1, app 2, app 3, many, right? So at the sender side, your transport layer is going to put some amount of information which is useful, which is going to be useful at the receiving end, so that this message is going to deliver to app 1, right? And that information, whatever you are seeing in this blue color, is your TCP header, right? Now this complete information, whatever transport layer is now good, it doesn't care how this data is going to deliver to the receiver or the destination. It just simply pass this complete information to network layer, right? Network layer sees this complete information. For it just a information, it's just a piece of data, right? So for transport layer, the data is whatever is coming from the application, and this is header. But for the IP layer or the network layer, what is data? Data is complete thing. This TCP plus this data, right? For network layer, because it doesn't understand TCP, whatever is coming from the transport layer, for network layer, it is just the data for it. And now it adds another information. And what is that information? Where this message wants to go, the destination IP address, because the duty of the network layer is to deliver this information to network layer or the host at the other end, right? So it creates the IP header, attach it to it, and what this IP header is going to contain, this is going to contain, it wants to go to 2.2.2.2, which is the destination IP address, right? It is as simple as that. Although these headers contains much more information, and if you really want to go a little bit deeper into that, I have a complete course on transport layer which is totally dedicated to transport layer, to TCP, and where we are going to learn TCP from scratch. So believe me, I cannot explain this blue header in just a couple of minutes. You need to spend time if you want to understand it, right? So TCP layer is here, then TCP just without irrespective, it doesn't need to know how this data is going to deliver to the transport layer of the receiver. It just say, Mr. IP or Mr. Network layer, I am sending you data. It is now your responsibility to send this data to the destination. Network layer say, okay, give me the data. So here is the data from here to here. This complete thing is the data for the network layer. It say, okay, I am good. Give me the data. I'll put another header on top of it, and then I will be sending it to my data link layer. And you understand why we are putting this layer to header, because network layer do not just care whether this data is going out of the Ethernet, frame relay, point to point. It just doesn't care. It sends its information to data link layer and leave to data link layer that now it is your responsibility to send this data to the destination, right? This is the whole sole purpose. And now at the physical layer, data link layer is going to pass all this information to physical layer. Now physical layer, because it cannot send 101010 out on the wire, right? So how it is going to send? If this is a wire, it is going to signal the receiver that if I am sending 5 watts, you understand it's a 1, right? In terms of bits. If I am sending 0 watt, it is only it is 0, right? So there must be some signaling mechanism between the physical layer, so that whatever the information data link layer is sending here, it is received at the physical layer, and the data link layer is going to get it, right? And once the data link layer going to get it, it sees the L2 header. It sees, okay, the destination MAC address is mine. If the destination MAC address is mine, this frame is for me, right? And then it remove this thing, and whatever is remaining, it is going to transfer it to the network layer. Network layer is going to check the IP header, because it can only understand IP header, right? It is going to see, okay, the destination MAC address is destination IP address is mine address. It is going to remove it, and whatever is inside it, it is going to deliver it to transport layer. Transport layer sees, okay, the transmission control protocol header is there, and it says that the data is for application 1. I should not deliver it to application 3 or 2. I should be delivering it to application 1. So this is how this complete information is exchanged over this physical medium or the virtual medium, right? It is as simple as that. Now the question arises, if you consider me, why I am going into so much detail, right? And the reason is, I want you to understand the nitty-gritties or the fundamentals of networking, right? I am an enterprise architect, right? I design network for enterprises. And believe me, if you understand the networking to its core, you can design the network. My aim is to make sure that whatever I know, I distribute it to you. I provide that knowledge to you so that you can design on your own networks, right? But these are the fundamentals. If you know, then you can stand in any podium with a great confidence, right? So if I give you an example, as a network engineer, as a network architect, I have seen most of the guys who are pretty comfortable with these three layers: network layer, data link layer, physical layer, right? If there is a protocol like BGP, OSPF, they are very, very, very good in that, right? Even I'm good with respect to BGP, OSPF, I'm good with respect to switching. So data link layer technology comes under switching and the switching part, and here this comes under the routing part. So routing and switching wise, we are good. But I have seen pretty less engineer, very, very few engineer or the network engineer who knows this transport layer also. And believe me, these guys have spent almost 100 to 500 hours in learning this network data link, or maybe more are. But why can't we just spend 10 to 20 hours in transport layer also, so that this is also our responsibility? We are going to take more responsibilities, right? So, and believe me, this is not difficult at all. The course is already there. But if you are going into a little bit deep of networking technology, believe me, understand transport layer also, understand TCP also, right? If I say transport layer, then mostly I'm talking about TCP, right? If I am saying, if I say network layer, I talk about IP most, and that's why basically this model name is TCP/IP, right? These are the most prominent protocols of this model, right? Having said that, I hope you have enjoyed this video. Try to understand the previous board, try to understand the previous questions, read, understand all the questions, go in a sequence, and you will be amazed that whenever we are going to finish with our 16th or 17th question, your knowledge, your network fundamental knowledge is going to be great. I'm pretty sure about it. Having said that, thanks for being a wonderful audience, and see you in the next video. Bye bye for now.